Hello, my name is Christine Allen. I'm a data scientist at Kensci Inc. Today I'll be demonstrating some of the features in our open source tool, FairMLHealth. I'll do that by taking you through two of our example notebooks that come packaged with the tool, and I'll also give you a preview of the new features in version 1.0, which we're releasing in a few days. There are actually quite a few open source tools available for fairness and bias measurement. FairMLHealth is distinct in that it's designed specifically with healthcare problems in mind, but it also provides a number of stratified tools to help you analyze several metrics at once on a large number of features and values. What you're looking at on the screen is the splash page for our GitHub repository. On this page you'll find quick links, installation instructions, and a quick start guide with a number of examples for the available features. In the repository documentation, you'll find more detailed information about the content discussed today. For example, our Evaluating Fairness resource provides detailed information about each measure, as well as guidance insofar as which measures may be appropriate and what boundaries might be considered quote-unquote fair. You'll also find a quick reference containing a set of summary tables with the names, definitions, and suggested ranges for the measures you'll see today, as well as for a number of other measures. There's also an in-depth list of references and outside resources which you might find useful, in addition to links to our previous publications and tutorials. When you're ready to apply these processes to your own models, I recommend checking out our blank evaluation templates, which are intended to streamline that process for you, and we have one for binary classification and another for regression. And finally, the notebooks you'll be seeing today are all in our examples and tutorials folder and can be viewed in GitHub. However, for today's purposes, I'll switch to active versions of the notebooks to make for a more interesting demonstration. This is our example tool usage notebook for binary classification. It uses a synthetic data set to enable feature demonstration. The setup of the data and models is really not important. What you'll want to focus on are the kind of tools that are available and their general functionality. Now is a good time to warn you that there will be a lot of text and quite a few tables full of decimal numbers on the screen. I encourage you to ignore all of that and focus instead on the general process of evaluation. If there is something specific that you should read, I'll point it out to you, and it will probably be highlighted as well. This will also be available online for you in the next few days. So first I'll show you our fairness comparison function, which is available in the report module there at the top of the screen. It can process either binary classification or regression models, and I'll show you an example of the regression features in just a bit. Included on it are some of the more common measures of group fairness, for example, disparate impact ratio, equal odds difference, and also some similarity-based measures, for example, consistency score. There's an integrated flagging function that will highlight values considered to be outside of the fair range. This is turned on by default, but there's an argument that you can use to turn it off. For example, the disparate impact ratio is 1.8, which is well above the higher threshold of 1.2, so it's being flagged. And the output also includes several data and performance metrics to assist in evaluation. False positive rate, true positive rate, for example, prevalence of the privilege class. But it is optional to be turned off, simply with an argument. You can see here I have a smaller version of the results. You can use this same tool to compare multiple models or multiple protected attributes side by side. Here's an example with multiple models. I've defined my test data, target data, protected attribute, and pass my models as a dictionary. I can name these anything I want to. It really doesn't matter as long as they align among the three. And here at the bottom, I'll move it up to the top, I have an example where I'm comparing two different protected attributes which are named accordingly. You can also see that I'm getting an error because my equal odds ratio is returned as an AND value. I'm looking at the false positive rate, and I see that it's 0, and I'm guessing that the privileged group has a false positive rate of 0, which is giving me a division by 0 error. However, the FairMLHealth tool comes with additional analytical tools that will allow me to dive a little deeper and verify whether that is true. Before I get to that, I'm going to show you the Bootstrapping utility that we've added. It's used to facilitate statistical significance testing, and this will accept any function that outputs a p-value, and it will run a customizable number of randomized tests using that function. There will be more information about that available in the release. As part of the measure module, here's an example of that, there are 4 stratified table generating features designed to facilitate rapid but detailed analysis of multiple metrics for any number of features and feature values. For example, cell number 12 here at the top is showing an example of our data table output. You can see that displays a feature name and feature value for each feature value, and then stratified versions of each of the statistics. I've named my target, example target in this case, and I have the mean, median, value prevalence for each of the feature values. It's designed to be flexible in terms of the inputs, so I can select the features of interest in one of 2 ways, either by passing a list of features or just by subsetting my input. Either one will work. It will also accept either pandas or NumPy inputs, and in some cases a list. We're also working on Databricks compatibility for a future release. The data table function can also evaluate any number of targets, and I use the term targets somewhat loosely here because in this case they could be anything. As you see in this example, I've just passed 2 columnar subsets of my X data, my test data, and the X argument will give me my features and feature values, and the Y argument will be a set of stratified features, or a set of stratified statistics, 1 for each column. And then finally about this, there's an optional summary row displaying metrics for the full data set. As you can see with all features, all values, you can turn that off with an argument. And also because these are returned as pandas data frames, you can quickly subset and shuffle them, for example, to evaluate all feature values with a low prevalence at once. In addition to the data table, there are stratified performance tables, and here I'll bring that up to the top. These include metrics like true positive rate, false positive rate, accuracy, similarly stratified. It's also, again, designed to be flexible, so if you're able to pass prediction probabilities, it will use them to output additional metrics. And it can be useful, as I mentioned before, in the case of the equal odds ratio that was undefined. I can output the results for that same feature, and I can see that the false positive rate for my privileged group was indeed 0. Another helpful tool in situations like that is our bias table. It's intended both for troubleshooting these cases, and it's also useful in general bias assessment. The way this report works is by assuming each feature value as the privileged class. So in this example, row 0, let's say, this is the set of measure values when evaluation assumes gender equals 0 to be the privileged class, and similarly in row 1, this is the set of measure values assuming that gender equals 1 is the privileged class. Because the fairness measures are included, there's also an optional flag specification, though that's off by default. And what's more, with these analytical tables, you can specify custom flag ranges for each measure so that you can flag using different boundaries for each measure if you wanted to. And I'll show you an example of that in a few moments when I take you through the regression examples. Finally, there's a standalone summary function, which is similar to the compare function I showed you earlier. The difference between the two is that this summary function can only take 1 model at a time. However, the benefit of this option is that it's designed to work with our new cohorting feature. For any of the 4 analytical tables I just introduced, the data table, performance table, bias table, or summary, you can now attach up to several cohort labels. Essentially, this activates a grouping function so that you can subset any of those tables relative to each cohort subset. And you can see examples of that here. And I'll just show you the first one for this demonstration. I'll put it at the top. So you'll see that it just attaches the cohort groups to the left of the existing table. And this can be useful, for example, in regressions, which I'll show you an example of in a second, or it could be used for problems of intersectional fairness, for example, to compare black women versus white men. Here is our example tool usage notebook for regression. We use basically the same synthetic data set here, and the same tools can be used for both model types. So rather than take you through each of those individually, I'll focus instead on what's different. There are few formalized measures for regression comparison regression fairness comparison, and among those found in our literature review, almost all apply to logistic regression alone. This is likely for several reasons. For one, in many cases, regression problems can be converted to binary classification problems by using some inherent threshold. Although not all regression problems lead to outcomes with clear boundaries, and human evaluation of such scores may be ambiguous or depend on outside factors whose evaluation is beyond the scope of the regression problem. Secondly, depending upon how scores are used, there may be multiple, if not overlapping, ranges for quote-unquote good versus quote-unquote bad outcomes. And lastly, the normalization process for target distributions requires statistical judgment, which impedes the definition of a single metric or set of boundaries applicable to all regressions. So for these reasons, only a few measures are included in the FairMLHealth tool. These were chosen for their likeness to well-known binary classification measures, and the fair ranges to be used in these metrics requires judgment on the part of the analyst. That said, we do provide default ranges in FairMLHealth. For ratios, they're the same as in binary classification case. A range from 0.8 to 1.2 is considered fair, as is the case in the MAE ratio here, which is almost 1.3. For the mean prediction difference, which is simply the between group difference in the mean predictions, the default fair range is 10% of the total prediction range. And similarly for the MAE difference, which is the between group difference in MAE, that default is for 10% of the range of absolute error. Moving on to the performance table, which is of course going to be different. We've included MAE, MSE, standard deviation of the error, R-squared, for example. Also, as before, there's a bias table, which works with both cohorting and flagging. In this example, you can see that I've defined custom boundaries for the mean prediction difference, and then I can just pass those in a dictionary to my bias table. Finally, as mentioned before, you may want to define custom cohorts relative to the true value of your target, for example. And here I have an example where I create tertiles of my target and pass those as cohorts, and they show up here on the left, and I can compare my low, medium, and high true values in the table. So that's it for our tool demonstration. We hope it's helpful in your analysis. If we can make it better, please let us know through our discussion board and issues pages on GitHub. Thank you for your time.